Right. So let's continue with this the color code. Okay. I think we are okay. So now let's see the functions of fuse and earth wire. So let's see the types of fuse we have is the cartilage fuse and the replaceable fuse. These are the cartilage fuse. Normally inside one is you can with glass, one is without the glass. Normally it has glass casing and you can see the what I call that the wire, okay, that we use inside the fuse. While for the other one, normally they just give you the rating. Okay, so the rating of fuse is the value of the maximum current that are allowed to flow through the fuse without causing the fuse wire to melt. Because when over current, when the current overloading, so the heat generator will immediately melt down the wire inside and then cause the whole circuit of your house, normally used in your house or premises, okay, getting stopped. This is to protect the appliances that connected after the what you call that. Okay. So the rating of fuse is the okay. So some common rating is 1 ampere, 2 ampere, 3 ampere, 5 ampere, 10 ampere, and 13 ampere. Okay. Normally the small one used for the small charger. So a fuse is a fine and short wire, this one, that will heat up easily and melts when the current flowing through it exceed the value of F, the value of the fuse, not F of the fuse. Okay, and if the wire of the fuse melt, the electricity supply will be cut off. So with this, it will protect the what you call. Okay, can you understand? All right, now let's see the what you call the next one. So a fuse functions as a safety device to protect the wiring and appliances against the excessive current flow. So like I said, when excessive current flow, so it will directly, the wire will be melting, so the whole circuit will be stopped. So this is to protect, like I said, to protect the wiring and appliances. And the fuse normally has a slightly higher rating than the magnitude of the current which flow in the appliances. Because if you put like when you're using 10 ampere and you use 10 ampere, cannot, because the moment you turn on your appliances, it will straight away melt. Normally it will be 1 ampere more, like 11 ampere, and then okay, because it's to prevent the excessive one, not to stop the appliances. Okay, it's not setting the maximum, it's to set a bit higher than the maximum so that it will stop if too much is going through it. Now, choosing the value of the fuse depends on the value of the maximum current that flow through a circuit or the electrical appliances. So for example, an electric kettle that uses a maximum electric current of 11.34 ampere, we should install with a 13 ampere fuse because there's no 12 ampere. You need to follow the standard they have. See, so that's why you use 13 ampere. So how we do this? By using the formula of this one. Current equals to power over voltage, because the formula is P equals to VI. So here, so determine the suitable rating for the fuse that should be used in an electric iron, which mark 240 volt with 2000 watt. So we put inside 2000 over 240, which is 8.33. 8.33 from the rate, the most suitable one should be 10. So we choose the 10 ampere. because it must be slightly higher than the current that you calculate out, the current that you calculated. Okay. All right. Now, when excessive current flow in the circuit, so what happens is the fuse will melt and break the circuit. So the earth wire that connect the metal part of the electrical appliances to the earth, it will connect there's an earth wire, this is leaf, this is earth wire. This earth wire, okay, the current, the lead current will be flow through the earth wire to the earth. So it carries the lead current from the appliances to earth. Normally, sometimes we call this process as the earthing of electric. Okay. All right. Now, so let's see the safety precaution in the use of electrical energy. First, do not overload electrical socket. So it means that the socket normally they will write down how much the maximum power or the voltage or the current that can be used. Do not overload it. And replace the old wire with a worn out insulation with the new wire, because the worn out insulation might cause electricity leak. Do not touch electrical appliances or switches with wet hand, because water is a conductor. But pure water not. Pure water is not a conductor, but the water that we normally touch is with filling. With filling means there's something inside, so that's why it's conductor. Do not poke anything into an electric socket. In case of an electrical fire, switch off the main switch, use a powder fire extinguisher to put out the wire, and call the fire brigade. Because why we cannot use water? Because water might channel electricity and accidentally kill the one who try to put up the fire. So in case of a person getting an electric shock, first, again, switch off the main switch. Then we use an insulator like wood, rubber, or plastic to separate the person from the source of electric shock. Remember, never touch the person with your bare hand, even you switch off the main switch, because there might be electric current still flowing inside the person. And give first aid to the victim after you confirm, and send the victim to the hospital. Okay. Can I? All right. Now let's see the next one. Calculate the cost of electricity consumption. Okay, first let's see the energy efficiency. It's the percentage of energy input converted to useful form of energy output. Like for example, the energy efficiency. The useful energy output divided by energy input supply times 100%. This is the formula. So for the example, it shows a lighted filament bulb. So the energy efficiency, you see 100 joule of input supply, but it was only 8 joule of useful energy output is in the form of light. 92 was waste or not beneficial into the form of heat. So we use the useful one. So 8 over 100 and 100%. So it's 8% only. Okay. All right. Then for electric power, is the rate of electrical energy, E, that used by an electrical device. For example, the formula is the energy used divided by time taken. Okay, is the power. So we can also use P equals to IV, where I is equals to current, V equals to voltage or potential difference. While for electric current is defined as the rate of flow of electric charge through a conductor. So electric current I in terms of ampere is equals to the column Q, the electric charge divided by time taken. Remember, the unit SI for time is always second, so we need to use second. And voltage as is defined as the electrical energy used to move a unit of electric charge Q through a conductor. So the formula is E over C. Voltage is equals to E over C. E over Q, sorry. Electrical energy used, E divided by electric charge, which is Q. Okay? You understand? This formula. Can I? All right. Now combine inside. So the electric jug shown in photograph is rated this one. Calculate the current that flows through it. Okay, try to do this. Okay, so let's see the answer. So by using the formula P equals to VI, so V moves here, I equals to P over V. P is 2,200, 2.2 kilowatt, 2,200 divided by V is 240. So it's 9.17 ampere. Okay. All right. Now let's see the cost of using electrical energy. So power is the rate of using energy, where the SI unit for power is watt or joules per second. So this is the formula, joule per second, where the electrical power is electrical use divided by the time taken. And then the electrical appliances are normally marked with the power and voltage rating, where power is voltage times current. Okay, IV lah. So the unit commonly used for the electrical energy is kilowatt hour, where the kilowatt hour is power in kilowatt times time in hour. And this is the unit. Kilowatt hour is the unit. So this is the cost of the electrical energy use is the electrical energy use in unit. This one is in unit times cost per unit. Okay, can you understand? Now, let's see the relationship between the power, voltage, and current. Now, for example, current is power over voltage because the formula is P equals to VI. So an electrical appliances is 150 watt and the voltage is 250 watt. So calculate the electrical current of the electric appliances. So we use current equals to power over voltage, 150 divided by 250 is it? Is 0.6 ampere. Okay. All right, next. The relationship between electrical energy, power, and time. So the electrical energy is power times time. That's how we mentioned. So an electrical appliances have a power of 1 kilowatt, which is 1,000 watt, used for 5 hours. Calculate the electrical energy use. So the power times time. You see, power must be in kilowatt. So it's 1 times 5, which is 5 kilowatt hour. Remember, to calculate this one, the unit is kilowatt hour. So you need to change your power into kilowatt, and your time must change into hour. Okay. All right. Try these questions. Okay, so let's see the answer. So a 2 kilowatt kettle, electric kettle takes 10 minutes to boil the water. So calculate the cost of the electrical energy used to boil the water if the rate per unit is 21 cents. So first we try to see this. Okay, so power 2 kilowatt times 10 minutes, 10 minutes, 10 over 60, because we have to change it into hour. So you get 1 over 3 kilowatt hour, which is 1 over 3 unit. Then is per unit is 21 cents. So you multiply with 21 cents per unit is 7 cents. So the cost will be 7 cents. You do it correctly? Okay, next. So the amount of energy used by the electrical appliances actually depends on two things: the power of the electric appliances and the duration of the electric appliances which is being used, how long they has been used. Okay, where 1 kilowatt hour is equals to 1 unit energy. So you see, this is the rate. Okay, in your textbook is for the first 200 unit is 0.128 ringgit. Then from 201 to 400 is 0.258, and additional and after the 400 unit, starting from 400 and 01 unit, so it will be 0.278 per unit. Okay, so for example, this is the electrical usage. So if 474 unit was used, he wants you to calculate the energy cost. So it's easy. 474, you can make it into 200. Next 100, which is 100, and next the other one is 174. So it's 200 times 0.218 is 43.6. 100 times 0.334 is 33.4, and the 174, the final 174 times 0.516 is 89.78. So total up is 166.78 ringgit. Okay, can you understand? All right. Now, next. So how shall we conserve the electrical energy? So the step to conserve the electric energy: first, turn off the lights that are not in use. Use fluorescent lamp, which are more efficient in lighting. Sorry. Iron all your clothes at one time. Keep, because when you switch on the iron, in order for you to iron your clothes, you need time to heat up the iron. So if you iron all your clothes in one time, you will able to save some electric on the heat up process. Okay, keep the refrigerator away from heating appliances like ovens, and do not open refrigerator door too often. And use energy efficient electric appliances in homes and offices. Those with sticker with how many star one. The more the star, the better the saving, the electric energy efficiency. Okay. All right, next. So now let's see the green building. The green building is the building that apply the concept of energy conservation, has succeeded in reduce the cost of electrical energy consumption. So among the features, first, they must have efficient ventilation system. This is to reduce the use of air conditioning and fan. Okay. Then they must maximize the use of natural lighting to reduce the cost of electrical energy consumption, and installation of solar panel as the renewable energy source to replace the conventional energy sources. Okay, can I? All right, now try to do this. Oh, sorry. Okay, seems like you have done. So let's see the answer. Right, so let's see the answer. Um, First, give the wait, wait. I think I better use. Okay, so let's see the. All right, now for question. What the hell? So the for question one, so gives the definition of energy efficiency. So energy efficiency is the percentage of the what you call of the energy input that converted into the useful energy output. All right, that's the answer. Now, yeah. Now for this question two. Now the electrical wait. So the electrical energy used by an air conditioner for 2 minutes is 180 kilojoule. So calculate the power of this air conditioner in the following unit. It wants you to in watt. So when it's in watt, so we use the formula A equals to P equals to E over T and put inside 180 kilojoule over by 2 minutes. So you can, this one change to joule, this one change to second. So 180K, 180,000 over by 120. So equals to 1,500 watt. Okay. Now, for the second one in kilowatt, so you need to divide by 1,000. Okay, so for this one, you need to divide by 1,000. So you use the power of air conditioner is 1,500 divided by 1,000. This one, which is 1.5 kilowatt. Okay. All right. So now let's go to question three. Yeah. Now for question 3, a microwave oven, okay, rated 1.2 kilowatt, okay, rated 1.2 kilowatt, okay, 240 volt is connected to 240 volt electricity supply. So it wants you to calculate the current that flow through the oven. So your answer shall be looks like this one, where we use P equals to VI, okay, and 1200 watt equals to 240 volt times what times I. So this one moves here, 1200 over 240 is 5 ampere. Okay, yeah. Now, for questions number 4. So an electric rice cooker, okay, is switched on for 30 minutes. Okay, switch on for 30 minutes. He wants you to calculate how much the electrical electrical energy is used by the rice cooker. And also he wants you to calculate the cost of the energy that is used by the rice cooker if the price is 30 cents per kilowatt hour. Okay, first up we try with the A first. So we use E equals to PT. Okay, we use E equals to PT, where 800 over 1000, we need to change into kilowatt times 30 minutes, convert into hour, so over by 60, sorry. So you get 0.4 kilowatt hour. Okay. Then for B, he wants you to calculate the cost of the energy used by the rice cooker. So it will be, because we already get the energy use, we already get the energy use here. So what happened is we just use the 0.4 kilowatt hour times 30 cents because it's provided at 30 cents. So total up is 12 cents. Okay. Then for number 5. First, what is the importance of the star rating labeling on an electrical appliances? So the star rating is actually indicate the energy efficiency. Okay, it's actually labeling about the energy efficiency. Okay, by of the electrical appliances. And how many star is considered at least should be used? So at least 3 star. Okay, we should use at least 3 star. Okay, at least 3 star. So the more star on what I call, the more star on the we call the electrical the label means that more energy saving. Okay, so do it correctly. All right, huh? All right. Now, should I give you the what I call? I send to you first. The slide. All right, so let's have a look on this. Chapter 7, where we're going to talk about the energy and power. Okay, now let's see the first one. Okay, so work, energy, and power. So work is defined as the product of force, okay, and displacement in the direction of the force, which is W is equals to Fs, where the SI unit for work is joule. So 1 joule of work is done when a force of 1 Newton is used to move an object over a distance of 1 meter in the direction of the force, which is 1 joule also equals to 1 Newton meter. Okay, then we have another called the physical quantity, is the moment of force and energy. There are 2 physical quantities other than the work, which also measured in the unit of Newton meter. So what is called the moment of force? Moment of force is actually the pivoting force, where the moment of force is actually the force that we use to do the rotating motion. Okay, so the moment of force is equals to force times perpendicular distance from the pivot to the force from here, which is 20 cm. You see, from here to the force 20 cm, so which is 0.2 meter, so it's 10 meter. 50 Newton times 0.2 meter, which is 10 Newton meter. So this is the formula. Okay, you understand? Okay, now let's see. You see, these are the works. So you see, when we try to lift and okay, so you see, he used 20 Newton up and down because the weight of this is 20 Newton. So when he lifting an object vertically through a height of 1 meter, okay, with a force of 20 Newton against the gravitational force. So you see, the force is 20, the direction of the force is vertical. So the displacement of the force is 1 meter. So from here to here is 1 meter. So the formula is work done is Fs, force was times the what you got displacement. So 20 Newton times 1 meter, which is 20 joule. For B, he pushed the trolley over a distance of 5 meters with a force of 10 Newton. So the force is 10 Newton, is a horizontal force. So the displacement is 5 meters. So 10 times 5 is 50 joule. And this one, pulling a drawer over a distance of 30 cm with a force of 2 Newton. So the force is 2 Newton, displacement 30 cm, which is 0.3 meter. Remember, must switch it to meter. So 2 times 0.3, which is 0.6 joule. Okay. Correct? Huh? All right, then try to do wait, okay. All right. So try to do these questions. This example one. Okay, so let's see the answer. So now, figure 7.2 shows a student weighing 400 Newton, carrying a load of 100 Newton while climbing a flight of stair of a vertical height of 3 meters. So calculate the work done. So the work done will be, because that people is 400, this one is 100. So you need to plus together. So you get 500 Newton times 3 meter, because it's going, we are talking about the displacement vertically. So it's 3 meters. So it's 1,500 joule. Okay, you did correctly. Yeah, good. So try this too. Okay. Right. So for the example two, figure 7.3 shows Ali lifting a box of mass 10 kg from floor to top of the cupboard. So how much work done by Ali? So it's 10 kg times 10. 10 Newton is 100 Newton, which is the weight of the box. Then by using the formula Fs, 100 Newton, no, 100 Newton times 2 meter, which is 200 joule. Okay, now a laborer pull a bucket of cement weighing 300 Newton from the ground to the first floor of a building using a pulley system. So the first floor is 10 meter from the ground. So what's the work done? So 300 times 10, which is 3000 joule. Okay. All right, now let's see energy and power. Now your school teach under where? Okay. What chapter 3? Wow, they are not gonna able to finish they are not gonna finish your what you call your syllabus on time, I think. All right, so let's see the energy and power. So energy is defined as the ability to do work. So the SI unit of energy is joule, while the power is actually the work done in a period of time. Okay, so it's in terms of watt, which is 1 joule per second. Okay, now you see, a monkey weighing 50 Newton climbed a height of 3 meters up the tree in 20 seconds. So the daily activity, the force used is 50 Newton. Displacement of the direction will be 3 meter. Okay, you said 3 meter up. So work done will be Fs 50 times 3, which is 150 joule. Time taken is 20 seconds. So the power needed will be work done by time taken, which is 150 over by 20 seconds, which is 7.5 watt. Okay. All right. Now let's see try to do this by using this way. Okay, so let's see the answer. Now, ISO pulling a box up a smooth ramp from A to B with a force of 30 Newton over a distance of 2 meters in the direction of the force in 5 minutes. So the daily activity is E. Okay, you say E. So the force, okay, is 30 Newton. Okay, displacement is 2 meters. So work done will be 2 times 30, which is 60 joule. Time taken 5 seconds. So you use P equals to W over T 60 over 5, which is 12 watt. Okay. All right. Now, for the next one. Okay. Like for this one, 150 Newton weight is lifted to a height of 1 meter in 0.5 seconds. So the daily activity involved will be F. So the force, this one any weight can use. The force used is 150 Newton. The displacement is 1 meter. So the work done will be Fs 150 times 1, which is 150 joule. And is in 0.5 seconds. So the power is P equals to W over T. So 150 joule over 0.5 seconds, is, which is 300 watt. Okay, so this is how the looks like. Okay, understand? All right, now try to make this your homework. Okay, okay, take a snapshot, make this your homework. So if you are done, then you're allowed to dismiss. Okay, bye bye.